right, so here we're trying to find the slant asymptotes of this function. Again, keep in mind, you're not going to immediately jump into long division. You're first going to ask, is that numerator degree one higher than the denominator? And in this case, it is, right? I have an x squared versus an x to the first. So that tells me, yes, I will have a slant asymptote. So then once I know I have a slant asymptote, I know that it's going to be the quotient that comes from synthetic division. So setting up my synthetic division here, I'm going to first make sure I'm from highest to lowest. So I always kind of write this as just a double check here, but I need x squared, x to the first, and then the constant. I will then list out those coefficients. So I have 5, -5, and -4. To the left of the L, I write the opposite sign of the denominator. So in the denominator, I have an x minus 1, so I will have a positive 1. And then I go through synthetic division by first bringing down the 5. You'll notice nothing goes in that second spot, in that second row. You just bring the 5 straight down. And then multiplying diagonally. So 5 times 1 to get 5, and then add vertically to get 0. And then 0 times 1 to get 0, and then add vertically to get -4. Now remember, the -4 is the remainder, so that goes over x minus 1. And then to get our quotient part, we are going to have 1 less than what we had in the original problem, in the original numerator. So this will simply just be a 5x plus 0. So what you'll see is that, yes, our synthetic division is 5x minus 4 over x minus 1, but all we care about for the slant asymptote is that quotient, not the remainder. So for the final answer here, when it says the slant asymptote, we will simply write y equals 5x because we're just interested in the quotient to identify that slant asymptote.